Hi everyone, welcome to our demonstration today. I'll be taking you through our proposed solution to problem statement 1, which is to filter out noise in online reviews. Today we'll be looking at our solution which we call ARC, which stands for Automated Review Checking with Machine Learning. So I'm going to take you through the steps on how to set up the repository on your local device, and then we'll be looking at how to replicate the inference process that my team and I did. And finally, we'll be doing something a little bit more interesting, which is to open up the minimal website implementation that my team and I have created just to see how we can interact with the model and see how it responds to different reviews. Okay, so before we get started on the implementation, I thought I should just take some time to talk about conceptually what's going on behind the scenes. So this diagram is meant to represent what exactly our pipeline is doing. Essentially what happens is that the review gets passed into the pipeline, and the review will pass through 3 different main steps. The first is a safety check. So if the review contains any kind of material that's toxic, that's hurtful, harmful, or offensive, it will immediately get rejected by our pipeline. If the safety check is passed, it will move on to the fast text models, which will check different things. Each of the fast text hits will check a different policy. Over here, I've shown that it will check for things like relevance, it will check that the review is not spam and doesn't contain any advertisements. If the fast text model is conclusive, then we can actually stop early and we don't need to pass the review onto the BERT encoder model. But if fast text is not conclusive and isn't really sure about whether or not the review should be accepted, then we'll pass the review on to the BERT encoder, and the BERT encoder will make the final decision. The point I'm trying to make here is that the review can get rejected at 3 different points in time. So it can actually pass the safety model check, pass the fast text models, and reach all the way to the encoder before the encoder finally determines that it should be rejected. Okay, so now I'm going to show you how to simply clone the repository. I've already created a folder in which I would like to clone the repository into. So I'm just going to run a simple git clone. Okay, so that's that. Now that we've cloned the repository, I can now access it. And so what I'll do is I'll create a virtual environment for our repository. We've used UV because it's really fast, and I can show you how to do that right now. So I'll first create environment using UV by calling UV-venv. This is created an environment. I'll then activate it. And so one of the best parts about UV is that it's really easy to sync all of your dependencies with the repository that you're working with. I can simply do this by calling UV sync. And just like that, all of our dependencies have been installed. Okay, so now that we've activated the environment and downloaded all the needed dependencies, I can now show you how to run inference using the Python script directly. We can do this by running the script as a module by calling UV run -m src pipelines inference pipeline. Much of the latency that comes from calling this particular script is actually not from the code itself. It's from pulling the model weights from Hugging Face to your local device. And so once the weights have been cached on your local device, every subsequent inference runs much faster. So you might experience some latency at the start, but after the first run of inference, you'll notice that any subsequent call of inference will be much faster. Okay, so that's great. So now we loaded our model from Hugging Face, and we've also run inference on 3 sample reviews which my team and I created just to test the inference pipeline and make sure that it works. You'll notice that for each of these reviews, if you look at how long it took to execute the prediction, it was actually really fast. So a lot of the latency does in fact come from pulling the model from Hugging Face. Okay, so I've shown you how to call the Python script directly. Now I'm going to show you how you can use the run.sh bash script, which is in the root directory, to do the exact same thing. In this case, the bash script essentially just calls a main.py file, which in turn calls the inference pipeline on just a single review. So all we need to do is to call run.sh, and you can already see how much faster it booted up. It's loaded the models, and then inference is completed in 0.029 seconds, so it's really fast. Okay, so now that we've seen how to run inference, the last thing that I wanted to show you was the minimal implementation of a web app, which will allow us to really play around with how we can interact with the model. So in order to do that, all we need to do is, once again, from the root directory, I'm just going to call the launch app.sh file. This will handle launching the front end and the back end for us, and it will take us to the browser immediately. So we're going to run this. Okay, and we're in the website. So there are a few examples that my group wanted to go through, and so all we need to do is to essentially fill up these little boxes, which would typically make up these fields would typically make up a typical review, together with some of its associated metadata on websites like Google Maps. So we're going to be using all fake names, fake reviews for this, but it's just to illustrate what the model is capable of doing. So first one we're going to do is we're going to do a market, so like sort of a grocery store, and it could just be something simple like and so for a review, we could do something that is clearly irrelevant, right? So it has nothing to do with Sunshine Market itself. It could be just a random user coming in to talk about something completely unrelated. So something like this. You can see that this person talks about joining a hiking club and they want to plan a trip to the mountains. So clearly stuff that's not really related to the market, and this means that the quality of the review itself is definitely quite poor, regardless of what kind of rating they give or anything like that. So all we need to do is to click Analyze Review, and you can already see in a split second the model has churned out a prediction. In this case, this output actually mirrors the output that we see in the terminal if a review is rejected at stage 2, which in this case is at the fast text hit stage. So over here we can see from the output that it has been rejected by the fast text hits, and the fired hit was irrelevant, which is correct because you can see that the review is clearly irrelevant. It's not really related to the store. Is talking about something completely different. So what would happen if I were to change this to make it something that's way more relevant? So I have an example here. So you can see that now the person is talking about the market, that they have good products, and that everyone should come by soon. And I can just change the rating, Analyze Review, and you can see once again in a split second it has definitely passed. This is clearly a relevant review. It doesn't violate any safety protocols, and there's no spam, no advertisements, so all of our policies were satisfied. The next review that I'd like to go through is once again just a random organization, and so this one is clearly a restaurant, and it could be something random as well, like Italian food. And so now we're going to test the model's capabilities in identifying reviews that are harmful, offensive, or just clear violations of safety. So you can see here already this review is very rude. Even though it technically doesn't use any vulgarities, it's probably not appropriate for a review platform. So if I were to click review, you can see it did not pass the safety check, which is actually the first step. So right from the get-go, our pipeline rejected this review because it violated safety protocols with a very strong probability. This is good news for developers like ourselves because we can see that the model is has identified this as something that is pretty toxic with a high probability. Yep. Okay, and the last review that we would like to go through is once again very similar. We could just do something again random like German cuisine. And so now what we're going to do is we're going to look at a little bit more of an ambiguous example. And what do I mean by that? Let's have a look. So you can see that this user overall would rate this as a positive experience, but they want you to avoid something. And so in this case, it's not rude, but it means that this person sort of disagrees with something that the organization does. And so what we want is we want the model to be able to identify that even when someone disagrees with something or disagrees that the organization is good or simply feels that it's not worth going to or that people shouldn't visit, the model is still able to identify this as a relevant review because it is a relevant review. It does relate directly to the organization, it provides an honest opinion, and it does so in a respectful manner that doesn't include spam or advertisements. So you can see here that if I were to click Analyze Review, everything is okay. And once again, you can see that the inference is extremely fast. So yeah, so with that, please do take a look at our repository. We've included the link in the description. Yeah, and thanks for watching.